Okay, let's take a look at this problem. Before we get into the math, it's only fair to warn you that I, as a math teacher of almost 30 years, spent about a half an hour to an hour on this problem. And I sort of fumbled around through lots and lots of trial and error. And I found two different ways to solve this problem in my trial and error, both of which are very complicated and may not be typical for a student to come up with on their own. So what you're about to witness is not meant to be something to say, hey, here's something you should have thought of. What you're about to see is really to show you the power of trial, error, and tenacity of me just not giving up on this problem and eventually sort of, I guess, stumbling across a solution. And a lot of times that's what mathematics is. So with that thought in mind, let's get started. So after many failed attempts, here's the one that succeeded. I realized we were trying to find the tangent of x here and that there was no tangent in this equation. I thought it might therefore be beneficial if I could get there to be a tangent in the equation. So I had a clever idea how to do that. I decided if I divided both sides by cosine x, then the left side of my equation would be a tangent. Sine divided by cosine is tangent after all. And what I've done here is I've traded in an equation with sines and cosines in it for an equation with tangents and secants, which isn't progress in and of itself other than the fact that I now have a tangent in my equation and maybe I can solve for tangent that way. That was my thinking. Now, I have a secant in this equation, and that's going to make it difficult for me to solve. But it occurred to me at this moment that there's an equation that secant squared is equal to tangent squared plus 1. That's one of our identities. And I thought, well, there are no squares in this equation, but if I squared both sides of the equation, there would be. So I was about to square both sides, and then I thought, well, I got fractions in here, that's going to get messy. So before I square both sides, to create a tangent squared and a secant squared in my equation, which I can then work with, I decided to clear fractions first. So I multiplied the whole equation by 2. No big deal, probably a smart move if you consider I'm about to square both sides and it's going to get messy with fractions, and I just didn't feel like dealing with that mess. So now, I thought about squaring both sides here, and I tried it and failed. And then I went back, and I thought, what if I isolated the secant first? And this is where my success came in. So I subtracted 2 from both sides, thereby isolating the secant. And it turned out, as you're about to see, this is where squaring both sides really paid off. So I've squared both sides of my equation here. On the left side, I had to use FOIL, of course, which I did, and it got kind of messy, but there's that. And at this moment, and again, this is after many failures, this is where I said to myself, okay, I'm glad I went this route, because by isolating the secant and then squaring both sides, I was able to use this identity and replace secant squared with 1 plus tangent squared. And now I have an equation with tangents and tangent squareds only. I've managed to use my algebra and trig skills to manipulate this equation to get rid of the secant. And now this is an equation I can solve. So what did I do? Well, I set my equation equal to 0 so that I could either factor or use the quadratic formula. Factoring didn't work, as it turns out. So I thought, well, I can use the quadratic formula here to solve for tangent of x. Now, just to make it appear a little easier, you could make a substitution any letter you want equals tangent x. I chose W for reciprocal, of course. And so by replacing tangent x with W, my equation now looks more like something you would see in 8th or 9th grade. And you kind of get the sense that you're actually solving a quadratic equation at this point. Not that you have to do this, but the substitution is a nice visual trick. So, looking at the right side of your screen, what I did next is I applied the quadratic formula. I will not show you my scratch work here, but I did do that and eventually whittled my way down to this, which, using some fancy radical algebra, simplifies down to this. Now, I won't go into all that because it's not the main point I'm trying to convey here, but I did use the quadratic formula to solve for W. But remember, W represented the tangent of x. Therefore, I have now solved for the tangent of x. Now, if you look at the top of the screen, it says we're supposed to find the tangent of x, and it appears as though we've done that, but there's a problem. This plus or minus here indicates that we've found two solutions, which in and of itself isn't a problem, except we were told, and if you go to Canvas and look at it, you'll see we were told that this problem only has one possible value of x. That was part of the given information. So if there's only one possible value of x, there can only be one possible tangent of x. Tangent can't be two different things if there's only one possibility for x, which again we were told in this problem. Now, which raises an interesting question then. Which one of these answers is the one answer to this problem? We found two of them. And this brings us back to a point about squaring both sides of an equation. You've probably heard this on very rare occasion, but whenever you square both sides of an equation, you run the risk of creating what's called an extraneous solution, which means it's not really a solution, it's a solution to the squared equation that wasn't a solution to the original equation. And if you're thinking, well, I was never told that, well, it doesn't come up very often, but it is a mathematical fact, and it's got nothing specifically to do with trigonometry. So by squaring both sides of this equation, we've created a second answer, which isn't actually an answer to the original problem. So now I've got to embark upon the task of figuring out which one of these answers is an answer to the original equation and which one isn't. Well, this was kind of tough and it took me a while, and I want to share my thoughts with you. This will show you the power of deductive reasoning. So see if you can follow me on this crazy logic. This equation caught my attention. And here were the thoughts that ran through my head. After many failed thoughts, this is the successful train of logic that eventually worked. We were told that x is between 0 and pi over 2. Think of it as an arc in quadrant 1 if we're thinking of this trigonometrically. So if x terminates in quadrant 1, then the secant is a positive number. If the secant is a positive number, then we've got 1/2 times a positive number plus 1. Wouldn't that be greater than 1? That makes sense, right? If you take 1/2 times a positive number and add 1 to it, you're going to get a result greater than 1. Therefore, the tangent of x is greater than 1. That's what I deduced from the line you see with the arrow in it, that the tangent of x has to be greater than 1. Now look at the bottom of the screen. This number, as it turns out, is not greater than 1, whereas the other solution is. Oh, how did I know that's not greater than 1? Well, the square root of 7 has to be 2 point something, right? So 4 minus 2 point something would be 1 point something, and 1 point something divided by 3 would be below 1. And so once I determined that one of my solutions is less than 1, but that can't happen based on prior information, I deduced that that is not a solution to this problem, and therefore the remaining solution is the solution I'm looking for. That was a tough problem. I hope you followed that. All right, that concludes this problem. Thank you.